In this video, we want to speak a little bit about the mathematical work that will take place in the course. So as you know, there are usually 3 mathematical assignments per unit. There's a Math Task 1, then a Math Task 2 a few days later, and that one builds on the ideas and maybe goes a little bit deeper from Math Task 1. And then there is a mathematics homework assignment that's due at the end of the unit, and that's just a small set of problems that connect to the math ideas or maybe go in a little bit different direction. We wanted to say explicitly that as you're working on these math assignments, that collaboration is acceptable, it's fine, in fact it's even encouraged. You can use classmates, you can use the instructors, you can use really anybody as a resource to just bounce your thinking around and to toss ideas back and forth and to try to push each other to deeper understandings. There is the discussion forum that's in Blackboard. It's kind of a permanent forum that it's just a space for you to use if you get stuck on a math problem or if you want to see what other people are thinking about it. Joanne and I will monitor that forum, so we will at least respond if you do have a question. But peers can also go in there and respond to the questions or see what the mathematical discussion is there. Now, we do want to say when you turn in your mathematics work, that will be on an individual basis, and so you will need to write up your own mathematical explanations in your own words. So you can't just copy each other's work and say, we worked on this together, here we're turning in 2 copies of the same thing. That's not acceptable. We do want to see it individually. You're also free to use different technologies. These can be resources or tools for you to help you in your thinking. So you can use GeoGebra, you can use Excel, Desmos app, you can use Wolfram Alpha. You can really use anything that you're comfortable with as being a tool to assist you in your thinking. But then, of course, in your explanation, you'll still need to describe the thinking and the ways that you use those tools to help you understand the mathematics. Next, we want to say a little bit about the rubric that we're going to be using for grading your mathematics work, and then we will talk about some of the different format options that you have for saving and uploading your mathematical work. So with regard to the rubric, your assignments are going to be graded on a 2-point scale for the assignment overall. So to get the full 2 points, we're going to be looking for a full explanation where we can see your mathematical thinking, you give justifications for what you did, and we can tell what it is you did and why. Also, to get the 2 points, it needs to be mostly correct mathematically. But it doesn't actually need to be perfect, it doesn't need to be 100% correct. What we're basically looking for is that there's not substantial flaws in the mathematics. 1 point would be if there are substantial errors or substantial incorrectness, where it actually is a hindrance to the mathematical work overall. Also for 1 point, it could mean you have an explanation there, but it's maybe not a full explanation or not a full justification. We are willing to throw a half point to you if you basically just show your work but don't give any explanation at all. That would be a half point, and then a 0 would be just an answer or nothing uploaded at all. That would be a 0. So how is it that you're actually going to write up and be able to turn in your mathematics work in this online course? You have several options. First of all, if you really just like to have pencil on paper and be able to write your mathematics on paper that way, you can just do that and then scan as a PDF your work and send that to us or upload it to Blackboard. You can also write your work on paper and then take a photo or even a video of your work as it's handwritten and then upload that to us. If you do videos, just please try to keep those modest in size so that we don't get overloaded with things. You can also use Microsoft Word and type up your work in sentence form using Equation Editor or MathType to display your mathematics equations or expressions. You can use Microsoft Excel. We might have some tasks that lend themselves to Excel, in which case you can go ahead and compute things on Excel and then use some of the cells to go ahead and type text where you explain your thinking. If you use apps, you can use Explain Everything like I'm using here, which allows you to show work on the screen and then narrate it as your explanation. Notability is another app that can do the same thing where you can show your work and have audio narration, or you can go ahead and type your explanations as well. You can also use GeoGebra if you like that. You can show your work in GeoGebra and then just insert text to serve as your explanation. Or if you're familiar and comfortable with LaTeX, or some people call it LaTeX, you can use that coding markup language as well to write your work in sentences and then have the mathematics equations displayed and integrated right into the text. Any of those are fine. Basically, you can save them in any kind of portable format and upload those to Blackboard. Any of those, though, we are happy to handle. Now we want to share some samples of mathematical work with you, and this will serve to share the correct solutions to Math Task 1 and Math Task 2 from Unit 1. but this will also be a way where you can see how you might turn in your mathematical work throughout the course. So our first sample is here. This is on Math Task 1, and this is a handwritten solution that was then photographed, and the photo file was just uploaded to Blackboard, and that's totally a fine way to do it. So if you want to read the solution and think about it, you can pause the video here. But what I'll just point out is that we do have the correct solution down here at the bottom, but the important thing is that we have explanation that goes all the way along. So this solution uses some combinatorics to justify the fact that there are 6 possibilities, and then so you have 6 ways that 1 can show up, 6 ways that 2 can show up, 6 ways that 3 can show up, 6 ways that 4 can show up for each place value. So this multiplication gives us 60 as the sum of the digits in each place value. And then down here there's some work to factor in the place values. So you have the thousands place, the hundreds place, tens place, and the ones place. Each of those you get basically the digits summing to 60, but the values therefore are end up being 66,660. So this would be a nice, a solution that would score a 2 because it has the explanation of the work to back up the solution. This one happens to be totally correct, but it doesn't have to be totally correct to get a 2. Here is another sample solution for that task. This one uses Excel spreadsheet, and it actually uses the spreadsheet to do some calculating, which is fine. But then also there are the explanations that are included here at the top and at the bottom, which are important. So even if you use Excel to do your solutions, you still need to insert some text to explain things in there. This one gets the same answer. Here you can see the approach that was taken if you want to pause and look at it. An important thing here was that Excel was actually used to compute this sum. So Excel was not just used to display the numbers, but it was actually helping with some of the computations. Now moving on to Math Task 2, here's a sample solution, and you can pause it if you want to actually read through it and get the mathematical ideas. But the key things we wanted to point out here was, first of all, this is using Microsoft Word. This solution, the person downloaded Math Task 2 as a docx file, and then just went ahead and continued typing right into that same file, and then you can upload it to Blackboard as a docx file. That's totally fine. Right here, we actually have an equation editor that was inserted. This one doesn't have a lot of equations. It doesn't have any algebraic equations. But if you are doing equations, it's nice to use equation editor or math type so that they can look mathematically correct, and it's easier for us to read. But yeah, the other thing here you can see a detailed explanation where this one basically takes you through the thought process. So it's not really laid out as a proof, it's actually laid out as sort of like, here's how I thought about it. I thought about this first, then I thought about this second, and I was able to work my way towards the solution. The solution is down here in bold, just it's easier to find, not necessary, but that's just kind of nice that the solution is there. But really what we're looking at overall is the explanation. One other thing we wanted to point out in this solution is that it's not 100% correct. The solution down here at the bottom actually points out that the person forgot the factor of 1. Now in the prime factorization of 72 you wouldn't include 1, but in the problem context you could have a daughter with age 1-year-old. So really that should be thought about, a 1-year-old daughter. This person realized they didn't think about a 1-year-old daughter, and the fact that they didn't account for that fully means it's not 100% mathematically correct. But for this course, that's not a problem. This would still be scored as a 2, which is the highest score, because we can clearly see the thinking, and there's a lot of good mathematics going on here, and it's well explained. And the fact that 1 wasn't accounted for, not the biggest deal. Here's another sample of a solution to Math Task 2. This one was written onto the page and then scanned as a PDF, and the PDF was uploaded to Blackboard. And this is, I think, actually a pretty nice way to turn in the homework, because by writing it yourself, you can lay things out in fancy ways. So like we have an equation, we have a comma list, we have arrows, we have a table, and then text kind of tucked in next to that. So this would be time consuming and kind of a waste of time to try to lay this all out in Microsoft Word, but a lot of us kind of naturally will write mathematics this way. We also wanted to include this solution so that you can see that having a clear communication of your thinking doesn't have to always be long paragraphs of text. Here, it's communicated just by flowing through the page that this person first thought about the product being 72, then they thought about the factors which led them to this table, and the table then allowed them to transition from thinking about the product to thinking about this other fact about the sum having to be the house number. So then we go to this text, and the text kind of gives the final reasoning about narrowing it down to this ambiguous case of the house number being 14, and then we get the solution down here. So this is also, it's not as polished and formal as the Microsoft Word version, but this would also be a very acceptable 2 for a solution because we can follow the mathematical thinking and we can see where everything came from and what the thought process was. So you have several options available to you for how you could write up your mathematical work and turn it in. Any of them are fine, so you can go with whatever is the most comfortable for you. And no matter what format you choose, it should be pretty clear by now that what we're really looking for is communication of your mathematical thinking. That's much more important to us to see how you're engaging in these mathematical processes and mathematical activities. That's more important than the answer itself that you get. It's also more important to see your thinking than it is that you interpret the problem correctly, quote unquote. So for instance, with the digit sum problem, math task 1, we were kind of expecting that each digit is used exactly once, but the problem is kind of vague, somewhat on purpose, so that you could have that thought and that thought process about, oh, what does this problem actually mean? If you interpret it to be repeated digits, that's completely fine as well. That's a legitimate problem. You can solve that problem and explain your thinking. Either way is actually fine, because if you're explaining your thinking, we can see how you thought about the problem, and there's some structure and patterns to find in either way that you interpret the problem. Just to really bring home the point that we want to see your explanations, here are a couple poor examples of math solutions. So for math task 1, here we have a lot of work that happened, thinking about a lot of different numbers, summing them up, doing some of that sum work manually. It looks as though this person eventually found some kind of structural argument, because this seems to be coming from a place of structure and place value, but it's not explained at all, so that would be a big problem for us. So this would still be like a half point, because you get the right answer, but we don't see any explanation at all in our grading rubric. Then over here we have another example, which is on Math Task 2. This person got to the right answer, or at least to the answer that we were expecting, but it's pretty much a complete mystery how they got there. They did a little bit of factoring to 72, but we don't know how they actually went through the logic and how they figured out that the answer would be 3, 3, and 8. So this, we would give them a half point because they did get the answer, but there's no explanation at all, so it's not going to be a 1. A 1 could be an explanation that's kind of incomplete, or an explanation that has some incorrect mathematics in it. A 2 is where we have a nice, thorough explanation, and most of the mathematics, a reasonable amount of the mathematics is correct. So there's a couple of half-point solutions. You can try to do better than that.